Hi, I'm Simon and I just want to show you my Hobby Components 8x8x8 LED cube kit. A bit of the construction of it and hopefully a working finished product. So here's the stuff you get with it. Now I was a bit impatient and I started building before I started this video. I just wanted to solder a few bits in. So at this stage we've got the nice black silk screen printed PCB, and I've already soldered in the 424 pin sockets, the 128 pin, the 16 pin, the 18 pin, the 2 push switches and the coaxial power socket. Now at this stage I have to resort to the instructions. So I'll just show you a few more of the components and then I'll start the proper build. We have 4 100 ohm resistors, we have 4 1k resistors, a single 10k resistor, we have 9 100 nanofarad ceramic disc capacitors, 2 22 picofarad capacitors, 3 100 microfarad electrolytics, a diode, a 7805 regulator, 4 DM13A chips, a 74HC238, an M54562P, an ATmega 238, a transistor, a crystal, 4 huge LEDs, a big bag of small LEDs, 4 various header strips, a coil of wire, a USB cable, and a template for aligning the LEDs when you're soldering them together. So I'm on it. Looks like there's a fair bit of information there, so I'm not going to bother printing it out. I'm just going to work in front of the computer screen. So first thing is I'm going to start assembling the board. I'm putting the resistors in. Don't be alarmed if you don't see these ones. There aren't actually any pads for these. This is for a different version. So, so it's just the other resistors you need to put in. The resistors have got lovely flexible leads and you really just have to bend them by hand. They're so flexible you're not going to stress the body of the resistor by bending them without holding them with pliers. So I'll just push them into the hole. Bend them over to stop them falling out. And just to be extra careful, I'm choosing to double check the resistor's the right one by measuring with a meter. You don't have to do this, but I think there's quite a lot to go wrong because there's so many components. So let's not make a silly mistake by putting the wrong resistor in the wrong place. Make sure you've got some nice precision cutters to cut these off after you've soldered them in. Don't try to make do with something like this, your electrician's cutters, because they won't be any good at all. The ceramic capacitors are all in now. As you can see, they've made it quite easy. You don't have to make reference to which one's C11 and C12. You just look at the diagram and the relative position, so it's quite quick to put them in. On the regulator, the instructions say you can optionally solder the tab of the regulator to the large square pad beneath it. That didn't sound like a very good idea to me, so I've chosen to use a screw instead. It's an M3 bolt. So I've just tightened the screw up slightly and soldered the 3 pins after I put the screw in, which seemed the right order to do it in. So now we're fairly close to finishing the PCB. The next stage is to put the little header pins on that the LED matrix itself will plug into. There are 2 strips of 40 header pins and you have to break them up into individual ones. You need 72, so there's some spare. I did try the long nose pliers, but actually I found these combination pliers a little bit better. So I've just got to break these up into 72 little pieces in the first instance. So now I have a pile of sockets, individual, ready to solder into the board. It's a good thing there are 1 or 2 spares because, as you can see, 1 or 2 break out of the plastic, just leaving the metal pin. So that one's scrapped. Also, when you're down to the last two, there's not enough to grab hold of, so you will need some snips to break these off. Note that these sockets have to be soldered on the opposite side of the board to the components. It's not a very easy process, to be honest, and I've to try and get them straight, because you can't hold them with your fingers because you get burns. So it's a bit awkward, but this is the method I found works for me. So what I'll do is I'll put 2 pins in, like that. And then I found something, it just happens to be a washer that fits across the 2. So hold it with that finger there, turn it over. I'll then turn it over with my finger still holding that washer that's holding the 2 pins on. And I'll solder the pins. So they should be pretty straight and I'm not burning my fingers. In fact, once you've got a few in, you can use the template to hold the pins in while you solder them. That's another trick. But I'll say this isn't a very fun process, soldering these pins in. It's just a bit of a pain, to be honest. Right, I think I've finally got a method. So if I put 8 pins in, like that, I've got my row of 8. Then put my template on so it misses the holes, so it bridges between the ones that are already soldered and the ones that I'm about to solder. Then if I very carefully turn this round, so now I've turned it round successfully without any of the pins falling out. Push it down to keep them nice and straight, and just solder them all. And then solder them. At last, I've got all 72 of the pins in. As I say, that's a bit of a pain. You'll sort of work out your own method to do it. But unfortunately, they do get too hot to hold them in with your fingers as you solder them. Now to solder in those jumbo LEDs at the corners which double up as feet. It does say in the instructions that if it's V1.1 kit, which mine is, the silk screen has an error. So that sort of cut off edge of the LED doesn't exist. So the way you work it out is the short leg goes into the square pad and the long leg goes into the round pad. And as you solder these, make absolutely sure that the LED is pushing firmly against the surface of the board on the other side, because that's going to take the weight of the whole thing. So now absolutely everything is soldered into the board, and it's time to insert the chips. You may notice the leads are ever so slightly wider than the socket. They just always are on ICs, I'm not sure why. So I'm just pushing them down a touch to make sure that they're the right width for the socket, just very gently. Make absolutely sure the chip is the right way around. If you soldered the sockets in right, there'll be a little notch at the top which matches the little notch on the chip. And once you're sure it's right, firmly push it down. As you push them in, make absolutely sure that all the legs are in properly and nothing's going to bend over. And as the instructions say, the microcontroller goes in the opposite way, so that's got the little notch at the bottom there. So all my chips are in now. So just make absolutely double sure things are the right way around. I'm a bit paranoid about this because obviously it could blow a lot up. So on the top 4 chips, the notches are to the top. On the microcontroller, the notches to the bottom. and on the other two the notch is to the right. And again, to double check, you can actually see on the silk screen, you can see the notch, and the notch matches the chip. So that's it for the board. The board is complete. All I've got to do now is solder 512 LEDs together. I think I'm going to have some lunch first. Back in a bit. Right, now for the LEDs themselves. So the first thing to do, as per the instructions, is insert 16 LEDs into the template with the shorter leg of the LEDs on the left, as the PCB is shown now. Now, one thing I've decided is this is going to be a pain, because when I put it down, the LEDs fall out because the PCB is thinner than the depth of the LED. So I'm going to make a little modification. So as I know I'm going to have to do this process a lot of times, I really do need to make it easy. So I found something suitable to prop it up, which it just happens to be a single UK electrical box. It can be a plastic one or a metal one. It can be anything you like, but this is just what I happen to find. And I've marked out a centre line, and I've marked 50 millimeters from the one end, and then 2 points 60 millimeters apart. And I'm going to drill whoops, a couple of 4mm holes like that. Then just going to screw it in. And I'm going to just very gently screw it on, not so it bends the board, just so it holds on. You could do this anyhow you like, or you could just stick some rubber feet under it if you have some, but this just happens to be the way that I'm doing it, because that's just what I happen to find in the cupboard. So now you need to grab the short leg at the base of the LED, so you're not straining the LED itself, and each short leg needs to be bent 90 degrees forwards so it can meet the next LED's short leg, until all 16 are done. Then we solder the short leg of one to the short leg of the next. That's easy. It's quite tricky. I think it's going to be pretty time consuming. That's it. So you've got to make sure the leads are together so you can heat them both with a soldering iron. That's something I don't want to be sometimes. Right, those are all done. I think the next row might be easier because we'll already have a load soldered together. Let's hope anyway. Next one is to do the same with the long legs, but instead of going downwards, we're going to the right. And as per the instructions on the template, do not bend long leg on last LED. So now to solder them. Right, so that's 2 rows complete. So as per the instructions now, we've got to pull the whole thing out of the template very, very gently and move it down so that the top row of LEDs is in the bottom row of the template. This time though, I'm going to bend the short leg forward in advance of putting it in the template because I think that's going to make it easier. So I'm going to insert my pre-bent LEDs. Then to solder them. So that's the short legs done for the 3rd row. Now to do the long legs. I'm going to bend them all to the right first. And then to solder them. That's the 3rd row done. And to just move it out one again. So again, I've pre-bent the short legs forward. I found that really helped. So I'm going to put those in now. Right, those are all in. Now to solder them. So now time to bend all the long legs to the right as before. And to solder them. Oh, it's only another 16 of these to do. As you can see now, it does actually have a bit of shape to it. So I've just got to do that a load more times. One thing I have found as I've been working on this is it's easier to turn the template upside down and work in reverse, because otherwise the bit that you've already done is going to be getting in your way. So it's definitely, I'm finding it easier to bend that short leg first. And the other thing I'm doing is I'm soldering each one as I go, rather than putting them all in and then soldering them. And obviously you can find your own method with this, and when you do something that many times, you are going to find your own best way of doing it. And at last, that is the first one finished. So I think I'm getting quicker at it, and I'm getting better at it as I get the hang of it. And also trying to film at the same time gets in the way a little bit. So I'm going to be timing the next 7 ones I make, see how long it takes. So at the end I can give you a rough idea of how long you expect the thing to take, and also to see how much quicker I get on each one I do. Now unfortunately, I had to do a bit of rework on the first 7 because I found there were quite a few LEDs that were faulty, and I thought maybe I'd damaged them with the soldering iron, the heat, even though I was careful. But in preparing them for the 8th grid, I found some more faulty, so it seems about 5% of the LEDs are dud. Now they do give you enough spare, so I've counted now that I've still got 8 spare after all this. So what I'll be tempted to do is test each one. It's a bit of a pain. If you've got a diode test function on your meter, connect the black lead to the bent leg and the red lead to the straight leg. That also makes sure you bent the right leg. So yeah, it takes a bit of time, but it'll save time of having to unsolder it if you find it's faulty after you've installed them. Now when we solder them, the leads actually need to be touching. The solder's not going to magically bridge across a gap. And the best way to make sure it touches is to make it slightly spring loaded. So if you look at this lead here, it's very, very slightly to this side. So I'm going to bend it that way, so it just rests on that. So there's a little bit of force pushing it that way to hold it together. Yeah, perfect. Nice little blob of solder there. Then the next one, so again it looks like it's pushing that way, so if I put the other side of the wire, then the springiness is bringing them together. And when we get to the end one, note, as per the legend on the template, do not bend long leg on last LED. That just goes straight upwards. So again, just spring loading that. One thing you will notice is you will get a huge blob of solder build up, so you need to use your sponge and will shake the solder off quite frequently. Right, my grid is now finished, and this is my final one. Now I'm going to test it again, and this might seem a bit obsessive, but it doesn't take very long. and I don't want to do any further assembly until I know that each one works. So I've got my meter set into diode test mode, and all I'm going to do is put the black lead onto the cathode and just touch each one in turn and make sure the LED lights. Move on to the next one. Oh, I've got one that doesn't work. And for the very last row, yeah, that all works. So it might seem a bit obsessive, but if you think about it, you've got 512 LEDs, you've got about 1,000 solder joints, and the chances of something being damaged by the heat, becoming faulty, short circuit, open circuit, and I'd rather make sure it's right before it goes anywhere near the chips that control and drive them. Right, so now they're all tested, it's time to insert the grids. So as per the instructions, with the extra row of pins on the left, place them in with the LEDs facing forwards. Now I haven't practiced this. Now it's a tiny bit fiddly, but not too bad. So that's my first one in. I find the pliers quite useful to just make sure they're properly plugged in. As you do this, you sort of get a feel for it. So there's a certain amount of flex in the LED grids. Also, you have to get them pretty square in the sockets. You can sort of catch the lead on the sort of springy mechanism of the turn pin socket, which then you have to lift it out and push it in again because it gets stuck. Right, so all 8 of the grids are now plugged in. Alright, so the next bit is I've got to solder the long leg from each grid to the long leg of the one behind. I'm not sure I'm really going to be able to film this very well, but what I am going to do is I'm going to use my template to make sure I've got the exact right spacing of the LEDs. So I've soldered this top row here. It wasn't too difficult in the end, but as I say, with the confusion of LEDs, it wouldn't have videoed very well. One thing I do notice though is the other side very floppy, and of course these are all connected together anyway through the thing we've just soldered. So what I've done, I've soldered a piece of wire across here just for support. So it doesn't provide, the connection's all provided at this side, and this just duplicates the connection, but it just keeps the LEDs stable. So now I've done all these, all the soldering across. Yeah, it wasn't too bad in the end. So the next thing is to link up from these 8 sockets here up to the individual rows. So I've got the grey wire that's supplied with the kit, stripped off the one end and plugged it into the header and cut it off for your mill above. So so that one's going to go to the top row, that one's going to go to the bottom row. I've stripped the other ends now and I'm going to solder them . Right, that's all soldered now, so finished in theory. I'll just go chop these leads off here. Yep, that all looks pretty much done. Right, I think it's time to actually plug it in. So I've connected it on the bottom to ground and VCC on that header. Let's go for it. Woo! I think we're going to have to try this in the dark. But first of all, let's have a summary. It's a lot of work. If you think my video is long and boring, it will take you twice as long just to do one of the 8 grids. Expect 12 to 15 hours of work to complete. Get the right tools, a decent soldering iron, precision cutters and smaller long nose pliers than the ones I was using. Take extreme care, visually check and test at every stage where possible. It would be difficult to put it right if it went wrong. It's a good kit I could recommend. There are cheaper ones about, but the instructions are pretty good, and I understand advice will be available in the event of a problem. Right, I'm just pressed reset. It's on its shelf. I'm just going to leave it for a bit.